Hi guys, I hope you are all doing well. Let's see today's question. So today's question we are taking this up from the topic of differential equations. And if I talk about the question which is given to us here from this topic, the question tells us let y equals y of x be the solution of the differential equation which is given to us as x cubed dy plus xy minus 1 dx is equal to 0, where the question further tells us x is greater than 0 means it's positive and y of half is given to us as 3 minus e. So the question further asks us to figure out what is y of 1 equals to. And if I talk about the answer choices that we have here, the options are 2 minus e, 3, the third option 1, and the fourth option given to us is e. So we need to figure out which one of the answer choices is the correct answer for this question that is given to us here. Let's try to solve this further. So I have my differential equation x cubed dy plus xy minus 1 dx equals to 0. Once I have that with me, I further try to evaluate this. I get x cubed dy is equals to minus of xy minus 1 dx. Now once I have that with me here, it basically makes it minus of minus 1, so plus 1 and minus xy dx and x cube dy. Now once I have this, I'll divide both sides by dx. So if I divide both sides by dx, this and this cancels, you get x cube dy divided by dx is equals to 1 minus xy. So further, if I try to evaluate this, I get dy over dx is equals to 1 minus xy divided by x cube. So that basically, if I try to separate the denominators, I get dy over dx is equal to 1 over x cube minus xy over x cube. So from here, if I see 1x gets cancelled, you get x squared. And further, if I try to evaluate this, I get dy over dx equals to 1 over x cube minus y over x squared. That minus y over x squared, if I bring it on the other side, becomes dy over dx plus y over x squared equals 1 over x cube. So that is the idea. And if I compare that with my general equation dy by dx plus py equals q, I get from here by comparison p is nothing but 1 over x squared, q is nothing but 1 over x cube. So once I have that with me, I have p, I have q with me, I will just figure out the other ideas. So let's see. I know integrating factor for such a general type of differential equation is given by e raised to integral p dx, which is e raised to integral 1 over x squared dx. And if I find the integral of x raised to minus 2 dx, I get that as x raised to minus 1 divided by minus 1. So that basically becomes e raised to minus of x raised to minus 1, which is nothing but e raised to minus 1 over x. So that's your integrating factor that we have. Now, if I talk about the solution of the differential equation, the solution of differential equation it's given by y into integrating factor. It is integral of q if dx plus c. So if I see here y if, that's your integrating factor, which is e raised to minus 1 over x, is equals to q in this case it's 1 over x cube, into if, which is e raised to minus 1 over x dx plus c. So from here, if I put, let's say, let's solve for this integral first. So I'm putting this as I, let's say, and in that, if I am putting minus 1 over x as t, what I get further is minus derivative of x raised to minus 1, which is minus 1 x raised to minus 2 dx equals dt. So from here I get minus of minus, so 1 over x square dx equals dt. So I have that with me. Let's try to split this. So I get from here, if I solve for that I, which is integral of this entire thing 1 over x cube, so 1 over x square into 1 over x into e raised to minus 1 over x. So if I'm putting minus 1 over x as t, so this basically I'm putting this as t, If I'm putting this as t, 1 over x square dx, this entire thing, this becomes dt. And since I'm putting minus 1 over x as t, this 1 over x which is present, that basically becomes minus t. So from here I get integral of minus t e raised to t dt. So minus 1 out, integral of t into e raised to t dt. That is nothing but using the idea of integral of u into v. So from here I get integral of u into v, which is basically u integral v minus big integral derivative of u integral v dv, the whole thing with respect to d. So we have to use that same idea. Here, if I talk about u and v, I'm just using the idea of Lie8. So choosing the orders I have, this is algebraic and exponential. So this algebraic becomes u and exponential becomes v. So t becomes u and e raised to t, which is present, that becomes v. So if I use that idea to solve this, minus 1 is out already as it is. So from here, what I get is t e raised to t, right? So I can just write u as it is, integral of e raised to t minus big integral derivative of t, which is 1, integral of e raised to t, which is e raised to t. Okay. So from here I get minus 1 t e raised to t minus integral of e raised to t, which is e raised to t. So you get from here minus 1 t minus 1 e raised to t. So from here, let's see further if I solve for. I have my solution of differential equation. So let's substitute that again. So solution of differential equation, which was y e raised to minus 1 over x equals integral of this entire idea. So minus of 1 t minus 1 e raised to t. So minus 1 t minus 1 e raised to t. Here I will resubstitute that again. So t in this case, we know it's already, t was basically minus 1 over x. So minus 1 over x minus 1 e raised to minus 1 over x plus c. So you get y e raised to minus 1 over x. So that basically minus 1, if I'm multiplying inside, it basically makes it 1 over x plus 1. So we get this idea entirely. Here you get minus t and plus 1, so you get that same thing. So once I have that with me, I can further write e raised to minus 1 over x plus c. So that basically becomes your solution of the differential equation. Now once I have that solution of the differential equation here, let's further try to solve this idea and get the value of this constant c. So if I want to get the value of this constant c, what I will do here is, I have my condition given to me that at x equals half, y is 3 minus e. So once I have at x equals half, y is 3 minus e, I'll put that here. And further, if I put it here, I get that as at x equals half, y is 3 minus e. So if I put it here, let's see. So I get 3 minus e raised to minus half, which is minus 1 over half basically, is equals to 1 over x, which is 1 over half, plus 1 e raised to minus 1 over half plus c. So from here, if I see what I get, let's see. So 3 minus e raised to minus 2 is equal to 1 over half, which is basically 2, 2 plus 1, 3, e raised to minus 2 plus c. So from here I get 3 e raised to minus 2 minus e into e raised to minus 2, which is e raised to minus 1, is equal to 3 e raised to minus 2 plus c. So this gets cancelled out, and when this gets cancelled out, I get the value of c, which is minus 1 over. Because e raised to minus 1, I can just write as 1 over e raised to 1. So 1 over e, c becomes minus 1 over e. Once I get the value of c here, I have been asked to find y of 1. So at x equals to 1, we have to find the value of y. So let's put it. So solution of differential equation, we have this y e raised to minus 1 over x is equal to 1 over x plus 1 e raised to minus 1 over x plus c. So c in this case is minus 1 over e. So we have this entire idea. Now if I just put at x equals to 1, what is the value of y that is asked to us? So at x equals to 1, we have been asked to find the value. So let's put that. So if I put x equals to 1 everywhere in this solution, I get y e raised to minus 1 is equal to 1 over 1, that is 1, 1 plus 1, 2. So 2 e raised to minus 1 plus minus. So basically it becomes minus 1 over e. So minus e raised to minus 1. So from here, if I try to solve it, I get e raised to minus 1 common, 2 minus 1 divided by e raised to minus 1, that's cancelled, y equals 1. So I get from this idea that at x equals to 1, y is also equal to 1. And if I see the answer choices that matches here with the question, it is option C. So C becomes the correct answer for the question that is given to us here. I hope you have understood how to solve this type of questions, which deals with the ideas of using the concepts of differential equations. I'll see you again tomorrow with some other question from some other topic, and we are going to continue our series of questions on JEE mains. So stay tuned for more videos to roll out. Also, if you're enjoying these videos that we are doing on everyday basis, please do like the videos as well and do subscribe to my channel and share this channel with your friends also who are involved in the preparation of questions on JEE, so they can also take the benefit from these questions which we are solving on everyday basis. Thank you.